Electrophoresis is a technique of genetic engineering useful to verify the integrity of the nucleic acids before use them in order to ensure the expected results. In this technique, the fragments of DNA can be separated by size using an agarose or a polyacrylamide gel. When an electric current passes through the gel, each fragment moves down.
As buffer of electrophoresis and for the preparation of gel can optionally be used TAE, triacetate EDTA, or the TBE, triborate EDTA. TAE has a smaller capacity of damping than the TBE and can be in acidification of meats if the electrophoresis is developed during a period very prolonged, but works very well with normal times of electrophoresis. In addition, it has a greater capacity of resolution than the TBE, but usually preparate-like concentrate solutions that can be stored to room temperature, previous sterilization in a sterilizer. These are diluted with water before each electrophoresis to obtain the used concentration 1x for TAE and 0.5x for TBE.
The first step was to prepare the agarose gel that consists in buffered TBI plus agarose. Then the gel went into the microwave to dissolve it. The gel cooled down, then stirred into the camera and waited until the gel was firm. After that, the cone was removed and the welds were performed. Then the gel were covered with buffer, and finally each team member filled one well using micropipettes. The voltage applied to the camera was 100 volts, 5 volts per centimeter. The first well is the marker, the second one is a PCR product. The band is a little bit distorted. That could happen because there is an accident of the sample. The third one is genomic DNA, and as the second one, it is a little bit distorted. The fourth well is a plasmid, and the bands are clearly distinguished. The sixth well is a marker, and the last one is a sample of RNA.
Gels, despite having different concentrations, show similarity in shape of migrating bands. The line number 1 corresponds to the marking red gel. Line 2 corresponds to the PCR, has an unexpected sample size because this was unknown, but the sample displays detailed in the three gels in lane number 4 that corresponding to the plasmid, it can be observed accumulate sample in the well. By observing migration patterns in different gel percentages, the distance are different because of porosity, but the TAA at 1%, the bands such as the marker, are distinguished. Pipetting technique was good because any burr-hole isn't break, but there is some excess of sample in the wells, although it is possible to see that the bands clearly. Voltage depends on the length of the gel. In this case, we use 100 volts.
Electrophoresis is a technique that allows the separation of DNA or RNA fragments to verify its size and integrity, using an electric current. Electrophoresis is important because other techniques like fingerprinting depends on it. In this practice, agarose gel was used because it does not denaturalize the samples, and after the process, they can be recovered. Depending on the concentration of agarose, we can separate large or small fragments.